Hello everybody, this is my video on factoring a sum or difference of cubes. In Math 3, this is the only new type of factoring that we've learned. It's really similar to a type of factoring that you would have been good, hopefully, from Math 1. And what we do is we have all these cubes that we're going to break down. But first, let's make sure you actually understand the difference between squares and cubes. So perfect squares are like when you take two numbers and multiply them, 1 times 1 is 1, or 2 times 2 is 4. So these are the perfect squares over here. 3 times 3 is, of course, 9. 4 times 4 is 16. And we can keep going for a while. And you really need to have some familiarity with these numbers sooner rather than later. Of course, 9 times 9 is 81. 10 times 10 is 100. 11 times 11. 12 times 12. And maybe up to about 13 times 13. Or like x times x is x squared, so x squared is indeed a perfect square, or any x to an even number. Meanwhile, though, perfect cubes is when you take three numbers of the same, and 1 times 1 times 1 is still 1, 2 times 2 times 2 is 8, so 8 is a perfect cube. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. So 64 is both a cube and a square. 5 times 5 times 5 is 125. And that's generally about the highest we go. And of course, also x times x times x is x to the third, or any x divisible by, with the exponent divisible by 3. So if you recognize these, and just to show you one from Math 1, what it looked like with squares, you'd always have like a difference of squares, meaning a subtract problem only, not a plus, not an addition problem. The way that split up was x squared easily split into x times x. You're going to see a lot of this in Unit 6. 121 splits up into 11 times 11. And to be a negative 21, one had to be a plus and one had to be a minus. So that was a really pretty simple type of factoring called difference of squares. Of course, the difference means subtract. Let's get more on that in Unit 6, but for today, what we're doing here in this unit is we have to be able to factor some difference of cubes, so we're going to need three numbers. So what I like to do a lot of times is make three little spots for x to the third breakdown, which would be x times x times x. Meanwhile, 64 would be 4 times 4 times 4. So again, three spots. Everything should be three of the same, hence they're cubes. From here, it's really just like following a map. I'm going to have a binomial, which is 2 parts, and a trinomial, which is 3. You put one of the front parts in the front, x, and the back part goes in the back. The other two that I haven't used, because I already used one x, the other two are going to go in the front here. X times x is indeed x squared. And hopefully you know what's going to go in the back, or hopefully you can assume the 4 times 4 is what's going to go in the back. So just put 16. In the middle is one of each, x times a 4, which is 4x. So I've got everything for the factorization. I just need to put in the signs. And for signs, I like to teach the use of SOAP. S stands for same. O stands for one of my favorite Math 3 words, opposite. And AP is always positive, or always plus, you can say. So again, same sign, and we started with a minus. So same, opposite, and always plus. This is the final factorization for this difference of cubes. So next up, I'm going to do the one from down here, x to the 6 plus 125y to the third. So I need to split up x to the 6 would be x squared, and x squared. That totals x to the 6. Or not totals, but multiplies to x to the 6. The 125 would be 5, 5, and 5, and the y to the third would be y, y, and y. So finally, 125y to the third is 5y times 5y times 5y. Same map. Remember, you need a binomial and a trinomial. Put one of the front in the front. Put one of the ones from the back in the back of the first parentheses. Put the other two in the front here, x squared times x squared is x to the fourth. Put two of these in the back spot. 5y times 5y is 25y squared. And one of each. So I got to do x squared times 5y. And they don't multiply together, but I can put them together in one term alphabetically. X squared is first, and then the y. The y didn't have an exponent. The x had a square, so I kept that consistent. Remember, same, opposite, and always positive. We started with a plus, so same, opposite, always positive. And again, this is my factorization for this sum of cubes in this case. Now, sometimes I've seen on Delta this other one of these may factor again. So if you haven't retained factoring knowledge from Math 1, we'll be going back to that in Unit 6. I'd rather say this topic for Unit 6, but my district wants it in this unit. So anyways, one more 8a to the third and 27b to the 12th. So breaking down 8a to the third, that would be 2a, 2a, and 2a. Breaking down 27b to the 12th. Hopefully you know that would be 3b to something. I'm not going to finish that yet. 3b and 3b. But what power would it be to make 12? Well, that would have to be 4, 4, and 4 to make 12. Remember, when you're multiplying, the exponents, they just add up. Same map. Binomial, trinomial. One of these in the front, 2a. One of these in the back, 3b to the fourth. Put those two together, 4a squared. Put these two together, 9b to the 8th. And finally in the middle again, one of each. 2a times 3b to the fourth. The 2 and the 3 will make 6 when you multiply them. Still a to the first, still b to the fourth. So for your signs, and then you're done. It's a minus, same, opposite, always positive again. Same, opposite, always positive. Hope this helps. Unit 3B for the delta, and let me know if you have any questions.